Hi guys, in this video we'll be going through the 2021 Acids and Bases examination. So let's get into it. So the first question is looking at the electron arrangement. So you will normally get the periodic table as well as the table of ions. So because I know this inside out, so I don't need it, but you will need to look at that. Okay, so if you look at on the periodic table, on lithium you find it's Li3, aluminium's Al13, oxygen's O8. You find it on the periodic table. Okay, so to write the electron arrangement, you just arrange it in this format. The first shell takes a maximum of two electrons, then extra go on the second electron onto the second electron shell, which takes a maximum of 8. The third one can hold a maximum of 8. The fourth one can actually hold a maximum of 18. But you don't need to go more than 2 because it's will only go up to 20. Okay, so for aluminium, because it's 13, so it's 2, 8, 3. So these three numbers should add up to the number at the top of the element. So this is 2, 6. Okay, very nice and easy. And aluminium and oxygen both form ions with the same electron arrangement. Okay, so aluminium, as we can see here, why do they form the same? Actually, why do I do that? Why do they form the same charge? Because what you need to do is look at the electron arrangement, right? So this guy has 283, so you know they want to have a full outer shell to become stable. So this guy has a choice. You can either lose 3 electrons or gain 5. Losing 3 is much easier than gaining 5, so it's going to become 2,8. And because you lost 3 electrons, you know, you become a 3+ charge. Because you lost 3 negatives, you're now 3 more positives. Now same with the aluminium. In this case, aluminium has a choice. It can, how does it have a full outer shell? It can gain 2 electrons or lose 6. So gaining 2 is much easier than losing 6. So this is also 2,8. Okay, so why these elements form ions? Remember, they gain or lose electrons to have a full outer shell to become stable. And this is how you can break it down. Okay, and people in my class, you know, people that I've taught will know this. I love using this method. So for aluminium, this is 13, so this is 13 protons, 13 electrons, and 13 electrons is 283, and one is 283. To have a full outer shell to become stable, they lose 3 electrons, so it's 2,8. And one is 2,8, you can add those numbers up, so it's 10 electrons and then 13 protons. That doesn't change. And now you can compare. You have 3 more protons, you have 3 more positive protons than negative electron. Therefore, the charge is 3+. So even without even answering, you know, in details of the paragraphs or whatnot, what I've just done here actually ticks off a lot of the merit bullet points, even sometimes the excellence bullet point. But you need an explanation to go with that. You can't just write this and expect to be given excellence. Okay, so same with oxygen. Let's try again. Same thing. This is 8 protons, 8 electrons. 8 electrons is 2, 6. So what that's going to do is going to gain 2 electrons to become 2, 8. I had 8 protons. Now I have 10 electrons. That equal to 10. So I have 2 more negative. I have 2 more negative electrons than my positive protons, so that's why it's O2 minus. Okay, so it's really important here, guys, that you need to remember that an atom will lose or gain electrons to have a full outer shell to become more stable. And in this case, you just need to compare how many protons and electrons you have, and that will give you the charge. Okay, so aluminium has 13 protons, 10 electrons because it lost 3, and that means it has a 3+ charge. Okay, very typical sort of question. Now next one, Ty point factory. So this is extracting aluminium, so explain the ratio. Now when you're doing the ratio question, you always need to cover these 2 following aspects. If you cover one of them, you get merit. If you cover both of them, you get excellence. Okay, so the first thing they even bullet pointed out for you, one is look at the charge, one is look at the number of electrons gained or lost. So let's go with the charge one. The charge one, remember, you need to have a neutral ionic compound. So what, because you guys are only year 11, when you do more chemistry later on, you know that this is not necessarily true. But when you have an ionic compound like this, the charge is neutral, which is 0. So that means they cancel each other out. So you can go Al is 3 plus, oxygen is 2 minus. So I need 2 Al3 plus to give me positive 6. I need 3 oxygen 2 minus to give me negative 6. My positive 6 and negative 6 cancel each other out to give me a neutral charge of 0. And if you can put what I've said in a sentence, in a paragraph, well done, you got a merit. So how do we get the other merit, which is, if you got both of these, you get excellence. You need to look at the electrons gained or lost. So let's think about this. Aluminium becomes aluminium 3 plus. Oxygen becomes O2 minus. So how did that happen? How did aluminium become Al3 plus? This guy lost 3 electrons. My oxygen, how did it become 2 minus? It gained 2 electrons. So here is where you need to understand, I need 2 aluminium will lose 6 electrons, and these 6 electrons are then gained by 3 oxygen, because if you times this by 3 times this by 2, this is 6, this is 6, so the 6 electrons that you lost by 2 aluminium is going to be picked up by the 3 oxygen atoms to become ions, and both of them are very stable in that particular way. Okay, so this is how you answer this type of question. So if you look at the answer here, so the ratio is 2 to 3. And you may go, how do you know that? You can just look at the formula Al2O3. So it's 2 aluminium per 3 oxygen. Okay, so this is the part aluminium will lose 3 electrons, oxygen will gain 2 electrons. So you need to lose. So what that means is that you need to have 2 aluminium that loses 6. So they lose 6 altogether, and then you need 3 oxygen to pick them up, which is the 6 electrons. Okay, and then in order to have neutral ionic compounds, the 2 gives it positive 6, the other 2 gives you negative 6, cancel each other out. This is an excellence question as well. Alright, next one, if you look at question 2, write a word equation. Now this is something that I mentioned numerous times with my classes. If you're someone sitting here that just want to get achieved, just want your 4 credits and run, never gonna take science again, totally understand, not everyone's subject, then I would strongly recommend not waste too much time on here. The equations are not a good way to get achieved text. Okay, like a question that we just did, like say these questions that we just done, you're far more likely to get multiple achieved text out of those questions by spending less time studying for it. Whereas for this, this is actually quite, you actually need to practice quite a bit. Just thinking about your investment of time and what you're going to get out of it. So this is only 1 achieved tick, whereas the thing that we looked at before could be 2 or 3 achieved ticks. Okay, but if you're interested, what we can do, this is magnesium carbonate. If you have a carbonate reacting with the acid, hydrochloric acid, carbonate plus acid, that's going to give you salt. So this is going to be magnesium chloride. That's our salt, magnesium chloride, and then we're going to make carbon dioxide gas, because that's what the carbonate is going to turn into, carbon dioxide, running out of space, plus water. I personally don't like writing this, because as a chemist, this is what we write. This takes so much less time, and carbon dioxide and water. Okay, if you can write these, this is merit, and if you can balance it, 2Cl, 1Cl, put a 2 here, that's 2 H's, 2 H's, everything's balanced, so this is an excellent answer. So like I said, if you get this, you probably won't need me to explain to you. Like I normally spend like literally 5 minutes teaching these balancing equations. If you get it, you get it straight away. If you don't get it, you might spend an hour, and that hour could have been spent somewhere else to secure your excellence. Okay, but to go into level 2 chem, it's really important that you know how to do these, because this is a fundamental chemistry. All right, next part. This is rate reactions. I don't even need to read the question here. So this is 37, this is 20. Explain which temperature has a faster rate reaction. Of course, it's 37 degrees. Refer to the collision theory to explain the effect of increasing temperature. So increased temperature does two things, okay? So increased temperature, that means that the particles have more energy. The particles, they will move faster. They will move faster with more kinetic energy. Okay, now this means two things. That means they will collide more often. There will be more collisions per second, per minute. They'll collide more often. That means there's going to be higher frequency of collision. Okay, so there's going to be more collision per unit time. Okay, now because they're colliding with more EK, then because they have more energy, a higher proportion of these collisions will have sufficient amount of energy, enough energy to actually cause a reaction. Why is that? Because they are now colliding with more energy. Because there's more EK, they're more often they're going to collide more often, and there's going to be the more of these collisions going to have more energy because they have more EK, and that means you're going to have higher number of successful collision per unit time. More successful collision per unit time, and that's going to give you higher rates of reaction. Very standard question. As you can see here, temperature of the hydrochloric insulation move faster, have more EK. So that means more collision per second because they move around more. And more of these collisions have sufficient amount of energy. So literally what I wrote. Okay, so it causes more collision per unit time. Now it's very important. You see this per second. You see this per second. It's important that you know when to use them. Per second just means I always give this example. If I say, all right, I have two people here, one earns $60,000 a year, another person earns $45 an hour, which person is going to earn more money? Then a lot of people look at me like, how am I supposed to tell? How many hours does that $45 an hour person work? Because the unit is not the same. So this is where per second, per unit time comes in. You need to give us the same time, the same frequency measurement, which is the time that we are we're looking at this with. Okay, now look at C. Instructions on how to ingredient can be swallowed whole or can be chewed in pieces. I'm explaining why. Okay, so into pieces, this is higher surface area, and when you have higher surface area, that means more of the particles will be exposed and they'll be readily available to react. Therefore, they're going to have a higher rate of reaction. Okay, so you just need to be able to recognize them. So you have true tablets will have a greater surface area, more likely to collide. Therefore, you have more collisions per unit time, and therefore you have more effective collision per unit time. The higher the rate of reaction, the more the gas is produced, and then the easier, the less pain that you are going to feel. Next one. All right, so this question is becoming more and more popular. A table like this. So you need to understand what they do with red litmus. Okay, so when you put soap and oven cleaner, in this case, into a red litmus paper, this will turn blue. This will turn blue. Because an 8 and a 12 means it's basic, and the base always turns red litmus paper blue. Universal indicator color, this will give you blue. This will give you purple. Okay, which indicator would you explain? Obviously, you use the universal indicator. Why? Because you can't tell which one's which by using the universal by using litmus paper. So very simple. Why would you use? It's kind of no-brainer. Why would you not use litmus paper? Because you can't tell which one's which because they're all bases. But then the universal indicator can be used because the purple tells us this is a strong base, and this is indicated by the 12. And then blue is a weak base because this is indicated by the pH of 8. Okay, so we can see here the litmus paper doesn't work that well. you know, so they'll turn it blue, so it doesn't tell you which one's which. But an oven cleaner will turn it deep blue or purple because it's strong base, but the other one will turn into a different color because it's a weak base. Okay, nice and easy. I think this is the last question. Oh yeah, this is the last question. Oh my god, what a short paper. Now let's have a look at this. So lemon juice is an acid with pH 4. So if it's pH 4, you are kind of like starting with a yellowish color, and then add also you're adding lemon juice to a beaker containing oven cleaner. And okay, so this is oven cleaner, so this is blue. They even gave you the color on the question. Oh my god, so you can actually use this to answer the question that we did just now. So we link the change. Okay, same typical question. All right, so we are starting initially, we're starting with the pH 12. Okay, so this is before any of the lemon juice has been added. You started with pH 12. That means this is a strong base. Okay, so this has your OH minus ions is a lot greater than your H plus ions. Your pH is 12, and then your color is kind of like a purplish color. Okay, so you have a strong base. This is what you have. But when you start adding the lemon juice, what's going to happen is that this will go down to pH 10 or 8 or 9, doesn't matter what it is. You can say 8 to 10. You add a bit of lemon juice, what's going to happen now, your OH minus is only going to be a little bit higher than your H plus, because now your pH is about 8 to 9, 8 to 10. It's still going to be greater, but this comparison, you're not going to have as much OH minus ions compared you used to have, because they have been neutralized. Okay, now if you add a little bit more, what's going to happen, you're going to have pH 7, your OH minus and your H plus ions is going to be exactly the same. You're going to have a neutral solution because you made neutral water, and you're going to see this pH 7 by seeing a color change of green. Now you keep adding lemon juice, more lemon juice, your pH is going to go to 4 to 5, because you are adding a lemon juice. Remember, the lemon juice is pH of 4. You're not going to go anything lower than 4. You can't go to red, and I think this is what they deliberately tried to do. You can't go to red because the acid that you're adding in is only a really weak one, so you can't go to pH 1. You're going to stop here. This is when your H plus ions is going to be bigger than your OH minus ions. OH minus ions, your pH is going to be around 4 to 5, 4 to 5, and then the color is going to be yellow, and this is where your reaction will stop. You have a small amount of H plus ions compared to the OH minus ions. Okay, so here you can see, here's the answer. You're going to see neutralization reaction by making water. When no lemon juice is added, pH is 12, excess OH minus ions. When you're adding it, becomes blue, pH 10 to 8 to 10, still more OH minus, but just not as big of a difference. And then when the concentration are equal, you make a neutralized pH 7, you add more, pH 4 to 5. Now you have more H plus ions compared to your OH minus ions. So very standard sort of paper. Nothing really out of the ordinary, so hope you check out my other level 1 science videos if you want. I don't know, this paper just feels really straightforward. So yeah, hopefully you found this helpful, and like and subscribe if you haven't, and I'll see you guys next time. Bye bye.